Okay, another quick video here, and the reason this is a quick video is because we're really relying on a lot of the things we already know how to do. When we solve an inequality, it's just like solving an equation, except instead of an equal sign here, we have a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. So it's just the sign that's different, not the process. If you still like to draw that vertical line, to remind yourself if you do something on one side you have to do on the other, go ahead and you can still draw that line there. If I want to get the x by itself, I'm multiplying by 2 and subtracting by 5, well I have to work backwards, so I'm going to add 5 to both sides. The 5's cancel. So I'm left with 2x is less than or equal to 23 plus 5 is 28. 2 and the x are being multiplied. The opposite of multiplication is division. Divide by 2. X is less than or equal to 28 divided by 2 is 14. The one added step, you can see it down here, star, star, okay? The one added step is you have to graph the answer on a number line. It's not just that x is equal to 14, it's that x could be anything less than, this is the less than sign, or equal to 14. Always read the inequality from where the variable is. So we need to graph our answer on the number line. So I'm going to put 14, 15, 16, 13, 12. So all you do is put, 3, 4, 5 numbers on in order, how they would be on a number line, using your value as sort of the center or near the center. Since it's equal to 14, I'm going to use a closed circle at 14, sort of like if it was equal to in the graph we did a solid line. And I'm going to draw an arrow where it's less than 14. So these values down here are less than 14. So I'm going to kind of do an extended arrow, kind of make it a little extra thick, showing it that these values down here are less than 14. What that means is that I could plug in any number that's equal to 14 or less than it, and it would make this inequality true. For example, if I did a check, I could use the number 0 because it's really easy to use and it's less than 14. So if I did 2 times 0 minus 5, is that less than or equal to 23? Well, 2 times 0 is 0. So yeah, negative 5 is less than or equal to 23, so that works. Okay? Let's look at another example. Again, same processes that we'd use. If you have a set of parentheses, you're still going to multiply, use the distributive property. 1/4 times p is just 1/4 p. 1/4 times negative 12, well, 1/4 of 12 is 3, and that's still greater than or equal to 2. I can do my line if I want. I can add 3 on both sides. So I have 1/4 p is greater than, that's positive 1. Let me move this line out of the way a little. To get rid of the 1/4, I can, remember to get rid of a fraction, we multiply by the reciprocal, 4 over 1. If I do it on this side, I have to multiply by the reciprocal, 4 over 1 on this side. So those cancel, so I'm left with p is greater than 4. So I'm going to plot my answer on the number line. Here's 4, 5, 6. Work backwards, 3, 2. It's greater than 4, not equal to it. So I'm going to keep it as an open circle at 4, and then make sort of my exaggerated arrow this way, the greater than way. Greater than 4. Okay? Again, even though we have 2 variables on separate sides, we can still draw this line and make sure that we get the variables together. So I probably want to subtract 2x on both sides. The x's cancel. 6x subtract 2x is 4x. Minus 7 is greater than 17. Add 7 on both sides. 4x is greater than, let's see, that's going to be 24. and divide by 4. This is going to work out nicely so that x is greater than 6. And again, here's 6, here's 7, here's 8, here's 5, here's 4. Open circle at 6, hopefully you're staying because it's not equal to 6, just everything greater than 6. And here we go. Greater than 6. Okay, one very special rule. When you divide by a negative on both sides of the inequality sign flips. Let me show you what I mean. Draw my line. I'm going to just start normal, add 7 on both sides. Negative 3x is less than or equal to 8 plus 7 is 15. Now, divide by negative 3. Divide by negative 3. Let's say I didn't know about this rule and I just kept going. So I said, well, okay, x is less than negative 5. So I plot my points, negative 5, negative 6, negative 7, negative 4, negative 3, less than or equal to, and so I think that my arrow is going to go, all the numbers that are less than 5 are this way. Okay? But when I go to do my check, let's say I pick negative 6 because that's less than 5. Is negative 3 times negative 6 minus 7 less than or equal to 8. Negative 3 minus 6 is positive 18. Minus 7 is less than or equal to 8. Well, 18 minus 7 is only 11. 11 is not less than 8. 11 is greater than 8. So it doesn't work when you divide by a negative. We need to go back. I'll get a different color and we'll fix it. Maybe you have a different color you can get too. Okay? We've got to go back and fix it so that when you divide by this negative, this step here, when you're dividing by negative 3 on both sides, we're going to change this inequality here so that it's greater than or equal to. X is greater than or equal to negative 5. I'm going to change this part here so that we're going to go greater than or equal to negative 5. Okay? Part of this, you can sort of think of it like in English, they always say you can't have a double negative. You don't want to say, I'm not going to the store. Does that really mean you're going to the store? Okay? So this very special rule, when you divide by a negative on both sides, to make sure it works, you have to flip the inequality. Let's just do another check so I can show you that it works now. Let's say I choose negative 4, because now negative 4 is greater than negative 5. So negative 3 times negative 4, subtract 7 is less than or equal to 8. That's negative 12. Minus 4, I'm sorry, positive 12 minus 7. 12 minus 7 is 5 is less than or equal to 8. That works. That's correct. Okay? All right, see you in class. Get ready to practice.